Greetings, Calc 2 students. This video is for section 7.3 and specifically from the exercise set from our book, problem number 4. We are asked to evaluate the integral of x squared divided by the square root of 9 minus x squared with respect to x. So the first thing I'm going to recognize is I have the situation where I have 9 minus x squared underneath the root. And this is something I want to simplify. So when I look at my table, I see that when I have the constant a squared minus the variable squared underneath the square root, then I should choose the substitution that x is equal to a times the sine of theta. In this particular case, 3 squared is equal to 9. So my a is equal to 3. And I'm going to substitute x is equal to 3 times the sine of theta. So let me write that out. 9 minus x squared, take the square root, is the same as 3 squared minus x squared, take the square root. So then I'm going to substitute 3 squared minus 3 times sine of theta squared, take the square root, and I'm going to get 3 squared minus 3 squared times sine squared of theta. And this is a 3 squared being taken out, leaves me with 1 minus sine squared of theta. And I get 3 squared times the Pythagorean identity of cosine squared of theta. And that simplifies to 3 times the cosine of theta. Now remember, from our table, we restrict the domain of theta to lie in between negative pi over 2 and pi over 2. So theta lies in between negative pi over 2 and pi over 2. So the cosine will always be positive in this case. So now we look at our original problem, and I have x squared divided by 9 minus x squared, take the square root, dx. And so I have found the substitution for this will be simplified to 3 times the cosine of theta. And so I just have to figure out the substitution for x squared. But that's okay, I know what that is. This was x, so I can square that. So let's do that. This is equal to the integral of x squared, which is 3 times the sine of theta squared, that's what x squared is now, divided by 9 minus x squared, take the square root, but that transformed into 3 times the cosine of theta. Now the only thing else we have to worry about is this dx. So we substituted for x squared, we substituted for the denominator, now we have to substitute for this dx. Well, we know that x equals 3 times the sine of theta, and so dx d theta would be equal to 3 times the cosine of theta. And so dx is equal to 3 times the cosine of theta d theta. And so now I can substitute this dx is equal to 3 times the cosine of theta d theta. And I will add that. So 3 times the cosine of theta d theta. Okay, so now we can just simplify a bunch of stuff. And I have the integral of 3 squared is 3 squared times sine squared of theta. And then this 3 and the denominator 3 and the cosine of theta and the cosine of theta, and the top and bottom will simplify and just leave me with the situation of 9 times the integral of the sine squared of theta d theta. We deal with that by saying that that is 9 times the integral of 1 minus the cosine of 2 theta, all divided by 2, d theta. And so this is equal to 9 over 2 times the integral of 1 minus cosine of 2 theta d theta. And from there we can say that this is 9 over 2 times theta minus 9 over 2 times the antiderivative of cosine is sine of 2 theta, and then we need to divide that by 2. And we also have an integrating constant of plus c. So then this simplifies to 9 over 2 times theta minus 9 over 4 times the sine of 2 theta plus an integrating constant of plus c. But the problem is we started out our problem with this function with x's in it, right? So 9 minus x squared on the bottom and x squared on the top. And we have our solution with thetas. Well, that doesn't make any sense, right? So what we have to do is transform our solution of thetas back into x's. So how in the world do we do that? Well, I know that I started with x is equal to a times the sine of theta, which in this case was x was equal to 3 times the sine of theta. So x over 3 is equal to the sine of theta. And that means that x over 3, when I take the arc sine of it, would be equal to theta. So I can substitute theta equals arc sine of x over 3 in for theta. But I also have the situation where I have to figure out what to do with this sine of 2 theta. So what I can do traditionally is draw a triangle. And I have x over 3 is equal to the sine of theta. So sine of theta is equal to the opposite over the hypotenuse. And so opposite would be x, hypotenuse would be 3. And from Pythagoras' theorem, I would calculate that this side would be 9 minus x squared, or hypotenuse squared minus the other side squared, take the square root. And we know that the sine of 2 theta is equal to 2 times the sine of theta times cosine of theta. So we already have sine of theta. Sine of theta is x over 3, and we need to multiply that by 2. So I'm getting that from sine of theta is x over 3. I need to multiply that by 2. And then I need the cosine of theta. So the cosine of theta is equal to adjacent over hypotenuse. And the adjacent then is 9 minus x squared, take the square root, over the hypotenuse, which is 3. So that is what the sine of 2 theta equals. So when I put all of this together, I have the integral of x squared divided by 9 minus x squared, take the square root, dx, is equal to 9 over 2 times theta but theta is equal to the arcsine of x over 3, then minus 9 over 4 times the sine of 2 theta. But the sine of 2 theta is equal to 2 times x over 3 times the square root of 9 minus x squared all over 3. And then I have to add an integrating constant plus c. So then this simplifies to 9 over 2 times the arcsine of x over 3 minus, and then 9 times 2 divided by 4 divided by 3 divided by 3 again simplifies to a half. And then we have x over 2 from this x. And then we have to multiply that by 9 minus x squared. And we still have to have that integrating constant of plus c.